Okay, good morning or afternoon or evening. Uh, Today we are going to get into the second unit in integrated math, which is going to be Introduction to Quadratic Equations. So I'm going to go over several examples as quickly as I can just to kind of get us started with quadratic equations. Okay, so first of all, we've got a very straightforward x squared equals 144. So what is the value of x so that when you square it, you get 144? So just like we do with linear equations, we're kind of doing opposite operations. So what's the opposite of squaring a number? The opposite of squaring a number is taking the square root. So if I take the square root of both sides, the square root of x squared is x, and the square root of 144 is 12. But it is also another number. There are two solutions to most quadratic equations. So 12 times 12 is 144. So the square root of 144 is 12. But there's another number that you can multiply by itself to give you 144. And that would be negative 12. Okay? So x squared equals 144 when x is equal to negative 12 or 12. All right, same thing over here. I take the square root of both sides to solve for k. Square root of k is k, except what is the square root of 19? It's not a whole number. It's not an integer. So we are going to leave it as the square root of 19. That's as simplified as we can get it. But also, it would need to be negative the square root of 19. Okay, so if you square either of those, you would get 19. Okay, so let's go one step further. If I have t squared equals 98, we are going to take the square root of both sides. And notice this says express all radicals in simplest form. If you had me for semester number 1, you would know that there was a section on simplifying radicals. So in this case, we are going to have to go ahead and simplify that radical. Okay, so first of all, we end up with t equals the square root of 98. Okay, but that can be simplified. Okay, so if you recall from last semester, I'm going to write the perfect squares on the side here. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and I'm just going to keep going for a little bit. Okay, now do any of those perfect squares go into our 98? Not 4, not 9, not 16, not 25, not 36, but the square root of 98 can be broken down into a perfect square of 49 times 2. Okay, that allows us to take the square root of the 49 and simplify that radical. So the square root of 49 is 7, and the 2 remains on the inside. So if you had me last semester, we spent some time on this. If this is new to you, you may need a little bit of additional practice, and we can talk about that if you need to. Instead of t equals square root of 98, the simplified form of that would be 7 square root of 2. And of course, I almost forgot that we have to have a negative 7 square root of 2 as well. Okay, so the solution to that particular equation would be that combination of radicals right there. Okay, moving on here. And if you want to, one idea would be if you want to stop the video right here and do the first 4 or 5 problems on the 2.2.1, you're welcome to do that. But I'm going to get into slightly different variations. Not very different though. So the square root of, take the square root of both sides, we end up with y equals the square root of 49 over 4. And that would be the same as the square root of 49 over the square root of 4. So in other words, if you take the square root of the whole number, it's the same as taking the square root of the numerator and denominator, which would be 7 over 2. And my answer would be 7 over 2, but also we have to have a negative 7 over 2 as well. Okay. Now, how about if we have a negative number? So z squared is equal to, if I were to have z squared is equal to 1, I would take the square root of both sides, and the square root of 1 would be 1. But what about if it's a negative 1? Okay, I can take the square root of z squared. That gives us z. But what number times itself gives us negative 1? In other words, what's the square root of negative 1? 1 times 1 is 1, so it's not a positive 1. And negative 1 times negative 1 is also positive 1. So there is actually no real number. Okay, so there is no real number. We'll learn about imaginary numbers at some point, but that's not a lesson for today. So the square root of a negative number is no real number. It would be imaginary, and we're not going to get into imaginary today. Okay, so let's look at some equations where we got to take a few steps to simplify. Okay, so I've got b squared equals, minus 10 equals 0. Okay, so this is just like a linear equation that we want to get the variable all by itself. So I want to move the 10 to the right-hand side. That leaves us b squared equals positive 10. Now I want to get the b by itself, so I want to get rid of the exponents. The opposite of squaring would be taking the square root. That would give us b equals the square root of 10, but also negative square root of 10. And there's nothing that we can do to simplify the square root of 10. So that's going to be the extent of our answer there. Okay, now we're going to look at a couple examples where you actually have to do what's called rationalize the denominator. Okay, so again, we're going to get our x by itself, so that means dividing both sides by 5. The 5's cancel out. I've got x squared is equal to 7 over 5. Okay, then I've got to take the square root of both sides. Okay, and that gives us x equals the square root of 7 over 5. Okay, let me bring that up here. Okay, and then we got, here comes Marco. X equals the square root of 7 over the square root of 5. Okay, good morning, Marco. I'm making a video right now. Good morning. I'll talk to you later, okay?
How much subscribers do you have now?
I got like 1 million. Get out of here.
I got like 7 trillion.
Okay. So I changed the square root of 7 over 5 to the square root of 7 over the square root of 5. That's the same thing. Okay, but we cannot have a radical on the bottom. So to get rid of that, I'm going to multiply the bottom by root of 5. Okay, so to get rid of the radical in the denominator, I can multiply by... Shut the door, guys. Okay, so now if I multiply the square root of 5 times the square root of 5, that would give me a denominator of 5. The square root of a number times the square root of a number gives you the original number. It's like inverse operations. And then on the top, we have that square root of 7 times the square root of 5 is equal to the square root of 35 over 5. Okay. And that is, we've rationalized the denominator. So there's no more radical on the bottom. So we're done. So x is equal to the square root of 35 over 5. And what did I forget? I forgot that there's a negative square root of 35 over 5 as well. Okay. I am not going to, for the sake of time, I'm not going to do that again. You can rewind it, watch it again, or just ask me in class and I'll go over it just so this video doesn't get to be too long. Okay. A couple more quick examples and we'll finalize the video here. Okay, so I'm going to simplify. I'm going to solve for y. So I'm going to add 5 to both sides. Okay, remember I'm getting my y alone, so that gives us 4y squared equals 26 plus 5 is 31. Okay, now I want to get rid of the 4, so I'm going to divide both sides by 4. That gives us y squared is equal to 31 over 4. Okay, now to get rid of the exponent, I'm going to take the square root of the left side and the square root of the right side. Now it's starting to get messy. Okay, so the square root of y squared is y. And I'll break this down into the square root of 31 over the square root of 4. That would give us the square root of 31 over square root of 4 is 2. Okay, is there anything that I forgot? Okay, negative square root of 31 over 2 and positive square root of 31 over 2. Okay, so let me do just one more example and then I'll let you guys get a little bit of practice in. Okay, so we have 7x squared minus 125 equals 2,500. Okay, so I want to get that x squared by itself. So I'm going to add 125 to both sides first. That gives us 7x squared equals 2,625. Okay, and then I'm going to divide by 7. I'm going to need a calculator for that. Give me a second. Where's my calculator? Oh, there it is. Okay. 2,600. Okay, that gives us 375. Let me move myself over here. So x squared equals 375. Okay, take the square root of both sides, and I get x equals positive square root of 375 and negative square root of 375. Okay, but one more thing. It says simplify your answer. So again, do I have any perfect squares that go into the square root of 375? In other words, can this be simplified? Okay, so I noticed right away that of my perfect squares, and I'm not going to write all those on the side right now, but I see that 25 goes in there. Okay, so a perfect square. So if I take 375 divided by 25, I get, 15. Okay, so again, I took a perfect square out. I took that 25 out. So now I don't need that. The square root of 25 is 5. And that 15 stays in. And my x is equal to that. And I'm done. Don't forget your negatives. Okay, so it's equal to 5 square root of 15 and negative 5 square root of 15. Okay, so there is an assignment and a quiz that go along with this. And feel free to ask me any questions during the practice and I'll help you out. Okay, good luck.